Alrighty guys, so in this video we're going to cover the notes on the product of powers properties. Those are 1 through 3. Those are from our first day of class, and our second day of class notes are problems or properties 4 through 5. So if you were in class to catch properties 1 through 3, you may skip to properties 4 through 5 now. If you need to catch up on the notes for properties 1 through 3, please watch this portion of the video. So the first property that we covered was the product of powers property. That says when multiplying like bases, you add the exponents. So an example of that is if I have x to the third times x to the fifth. This really says x times itself 3 times, multiplied by x times itself 5 times. So in total, x is being multiplied 8 times. So we get that by adding our two exponents, 3 plus 5. The second property is the power of a power property. So this talks about raising a power to another power. So when raising a power to a power, multiply the exponents. So an example of that is if we have x to the fifth squared. That's like saying take x to the fifth and multiply it by itself twice. According to our last rule, when we multiply like bases, we add their exponents. So we would add 5 plus 5, which is 10. Or simply just multiply the two exponents. 5 times 2 gives us a final exponent of 10. The power of a product property talks about when we're multiplying two things together and raising that to a power. I call this distributing, but not distributing. When raising a product to a power, raise each factor to that power. So an example of that would be if I had a times b, all raised to the second power. I want to make sure that both a and b get the second power. So this becomes a squared b squared. So you can see why I call it distributing, because each power is going to get the power of 2. But it's technically not distributing. Distributing, you remember, is when you multiply two things being added together by a factor. So it's not distributing, but it's quite similar. Couple examples before we move on. The first one is 9xy all squared. So we're going to use our third property to simplify this one. So I'm going to distribute, but not distribute, the squared to all three factors inside the parentheses, giving me 9 squared, x squared, y squared. My rule is if our final answer has something that is, if it has a number that's to the power of 5 or less, I actually want you to do that out in your calculator. So 9 squared is 81, x squared, y squared. Alrighty, the next one, I want to distribute again, but not distribute, the 2, the squared, to -4 and to x, giving me -4 squared, x squared. -4 squared is -4 times -4, which is positive 16 x squared. This is in contrast to -4x all squared. With this one, since the negative is outside of the parentheses, I want to square everything inside the parentheses first, giving me 4 squared x squared, and then make all of that negative. So my final answer here would be negative 16x squared. So just notice the difference between the placement of the negative. This one, the negative was inside the parentheses, giving me a positive result. This one, the negative was outside the parentheses, giving me a negative result. And then the last one. The first thing I want to do is take care of this exponent by giving it to the 2 and to the x cubed. So I have 2 squared. X cubed raised to the second power is a power to a power, so I need to multiply the two exponents, giving me x to the 6th, all times x to the 4th. So again, I have something that is raised to less than a power of 5. So I'm going to actually do that out, giving me 4. And then I'm going to multiply x to the 6th times x to the 4th. Since they're like bases, I add the exponents, giving me x to the 10th. Alrighty, this is where those of you who were in class yesterday and got the product of powers property should be jumping on in. When dividing like bases, we're going to subtract the exponents. So, for example, if I have x to the 6th divided by x to the 2nd, this is similar to saying x times x times x times x times x times x. X times itself 6 times divided by x times itself twice. I know x divided by x, a number divided by itself, is 1. So these guys can just cancel out. Same thing here. X divided by x cancels, leaving me with 4 x's being multiplied. So we write that as x to the 4th. As you can see, all I did was subtract 6 minus 2. The number of x's in the numerator minus the number of x's in the denominator. So when dividing like bases, subtract the exponents. Our last property is the power of a quotient property. When raising a quotient to a power, so when raising two things being divided to a power, give the power to both the numerator and the denominator. So if I had a divided by b, all raised to the 3rd power, this is kind of like distributing but not distributing again. I want to give the 3 to the a and to the b, leaving me with a cubed over b cubed. Alrighty guys, let's finish up with a couple examples. So the first one, negative 5 over y squared. I want to give the power of 2 to both things inside the parentheses. Notice where the negative is. The negative is inside the parentheses, giving me negative 5 all squared. Really important where they put the negative. Over y squared. Negative 5 squared is positive 25 over y squared. With the next one, I want to distribute but not distribute, the power of 3 to every single factor. So all 3 things need to get that power of 3. X to the 2nd raised to the 3rd power. A power to a power we multiply, giving me x to the 6th, over negative 4 cubed x to the 3rd. Now negative 4 cubed is negative 4 times negative 4 times negative 4. So this result is going to be a negative. Anytime it's an odd power of a negative, our answer is also going to be negative. Over here, we had an even power of a negative, so our answer was positive. So that gives me one more step to simplify. X to the 6th over x to the 3rd is dividing like bases. When we divide like bases, we subtract. 6 minus 3 is x to the 3rd. That x to the 3rd is going to stay in the numerator. Because we have 6 x's here and 3 down here, 3 of these x's cancel with 3 of these x's, leaving me with 3 in the numerator. And that's all over negative 64, which, since this is a positive divided by a negative, could be written as an entire negative x to the 3rd over 64. Both answers are correct. Last one. So the first thing we want to do with the last one is distribute, but not distribute, the 3 inside of the parentheses to all 4 factors, to the 2, to the 3, to the x, and to the y, giving me 2 cubed x cubed over 3 cubed y cubed. A common mistake is for people to miss giving the numbers the power as well, so don't forget to do that. And that's all times y to the 5th over 16. 2 to the 3rd is 8 x cubed over 3 to the 3rd is 27 y cubed times y to the 5th over 16. To make it easier for yourself, look on the diagonals at the 2 numbers that there are. 8 and 16. They both have a common factor of 8. So since they're on diagonals, I'm going to cross cancel. 8 goes into 8 once. 8 goes into 16 twice. So those two numbers reduce. Since it's a fraction, I'm going to multiply straight across. 1x cubed times y to the fifth is x cubed, y to the fifth, over 27 times 2 is 54, y cubed. I know I'm done when I have each variable in one place. Since I have y in two places, I need to go one step further. They're being divided, so 5 minus 3 is y to the second. So I'm left with x cubed, y to the second, all over 54.